We're always getting requests to do our installs without all the usual high-tech, state-of-the-art tools and equipment that we normally have at our disposal. To that end, we're going to totally caveman this install. No press, no gear pullers, no bearing pullers, just a hammer and some sockets and, basic tools. And of course, a couple of electric impacts, just to keep it real. Before we got to this point, we've drained and attempted to clean up the case down at the local car wash. We already pulled off the driveline yokes. You can just tap them off with a hammer if you have a little trouble getting them off. Remove the cover bolts using a 1/2-inch socket and remove the gasket. Move to the rear output housing. With the speedo removed, take out those 5 housing bolts. You can use a 9/16 socket. The housing can be removed with a little light persuasion. The input bearing retainer is held on by 6 3/16 Allen head bolts. Pry it away from the case, but be careful with that seal surface. Remove the retainer bolt from the intermediate gear shaft with a 1/2-inch socket. The intermediate gear shaft can now be driven from the case, from the opposite side of the bolt that you just removed. Normally we would be using a brass drift to avoid shaft damage, but in our back to basics mode, we'll just use a piece of mild steel that we found. Don't panic when you hear all kinds of small, important sounding parts dropping into the case when you remove the shaft. It's all good. If one of the side shims is easily accessible, go ahead and pull it out. It'll actually make that intermediate gear a little easier to remove. Fish out all 48 roller bearings. You'll need them later, as well as the 3 spacers. With the intermediate gear out of the way, completely loosen or even remove both of the exposed shift fork set screws. Use a 3/16 Allen. You will need to back the set screws out a long way because of the way they index into the shafts. Remove the 4 output bolts in the bearing cover plate, but save those shims. Move to the opposite side and remove the output cover by removing the 5 bolts using a 9/16 socket. Use a dead blow hammer to break the housing loose, then work the entire assembly out. If your shift fork set screws are loose enough, the shift fork rails will slide right out of the assembly. You may need to help them along. Remove both shift forks. Remember their orientation. Yeah, right. Well, we'll show you how to put them in later. Okay, if you don't have a press, it's hammer time. The bearing is the only thing holding that large gear in place. Once it's removed, we'll be able to remove the shaft and gears. While holding the gear against the case wall, use a soft metal shaft or a drift or a punch to drive the bearing from the front output. It'll take some abuse, but it'll go. Have a friend with angelic hands catch the shaft and gear assembly as you drive it out. Remove the remaining gear and shift collar. To get the final shaft and gear assembly out of the case, slide the shift collar off and position the large gear surface flush against the wall of the case. We'll actually be using the gear as a kind of puller by driving the shaft through the bearing. We are installing a heavy-duty 32 spline output in our case, so we won't be reusing our existing output shaft. If you are reusing your existing output, use extreme caution on those threads. A junk socket became a specialty bearing driver. Remove the gear and any other residual parts in the case. Using one of the gears that we just removed as a guide, mark the case. We're going to be cutting a clearance notch that will allow the larger gear for the low range kit to be installed. Just do a quick check to make sure that the slot you cut is wide enough to allow the gear to pass through. With the new larger gear just held in place, we can see the reason that new shift rod has a large notch machined into it. We're going to be needing that added clearance. Remove the shift rod cover using a 1/2 inch socket. For easy access and just a way to hold that shift assembly in place, we simply used the case as a mount and rotated the assembly and threw in a bolt to just hold it in place. Now a vise would also work great, but just don't destroy that seal surface while clamping. This shift rod install can be a real nightmare, but it doesn't need to be. Move both of the original shift rods in until they are pushed in even with one another. If they're positioned correctly, by looking at the opposite side of the shaft, you will just start to see those detent indexing marks being exposed. Remove the sensor and detent cap. Use a 7/8 end wrench on that sensor. It's a good idea to mark the housings so that you'll remember where to install that sensor. We used an Allen wrench and rotated the shift rod that will be replaced counterclockwise, just 1/4 of a turn. There will be slight resistance from the detent, and the slot in the shaft should now be vertical. You should now be able to pull the shift rod from the housing. Caution! There is a spring-loaded detent ball that will leave that housing at escape velocity and possibly chip a tooth unless you block its trajectory by putting your fingers over the ports. Trust me, it's hard to find it when it does shoot out. When we reinstall the spring and ball, we're going to add a small washer that is included in the kit to stiffen that detent pressure, just a little bit to help with that very common Dana 300 popping out of gear thing. The washer will be installed between the spring and the detent ball. We wanted to add that detent pressure increasing washer to both of our shift rails. Otherwise, you wouldn't even need to remove the second shift rod. Rotate the remaining shift rod 1/4 of a turn counterclockwise this time, and slide the shaft out using the same precautions for check ball launch prevention. The angle that we have our transfer case housing supported allows the shift bullets to drop into the shift rod passageway. Now you've got 2 choices here. You can fight them with a magnet or a pick and push them out of the way and then use some grease to hold them, or simply rotate the case and let them drop back into their passageway, which will allow the shift rod to be reinstalled. With their shifter bullets out of the way, we can easily retrieve the detent ball and install that additional washer. When dropping the ball in, use the shift rod as a stop. Just push it in far enough to hold that check ball into place. Okay, now it's going to get a little rough. We need to push that detent ball down into its passage by compressing the spring while simultaneously pushing the original shift rod back into place. A small tip screwdriver works pretty good. Once the shaft has the detent ball completely covered, just rotate the case back up to its original position. Push the rod back into its housing until that detent slot is just starting to be exposed again. Rotate the shift rod clockwise this time 1/4 of a turn, just back to its original position. You should be able to feel that detent ball drop into its notch. Remove the original rod and slide in the new replacement. Drop in the spring and washer. And once again, use that shift rod to help position the detent ball. Use the same screwdriver check ball depressing technique and push the shift rod in until it completely covers the ball. Tap the rod a little if necessary. Once again, push the new shift rod in until the detent slot is just starting to be exposed. Rotate the shift rod counterclockwise this time, a quarter of a turn, and you'll just feel that detent ball do its job. We could have replaced the seals while the shift rods were removed. It's really much easier. But we wanted to protect the seal surfaces from being cut by the sharp detents in the shift rods during install. The seals can be easily removed by using a small chisel and just catching the edge of the seal and popping them out. Take a second and clean up the seal housing. Carefully install the new seals, taking care not to cut the seal on that shift rod. Gently tap the seals into place. If you can scrounge up something to push the seal straight in, it makes for a much easier install. Reinstall the seal retainer. Reinstall the sensor and plug. We happen to know where that sensor goes because of our clever housing mark. Let's start with the front output shaft. We're going to replace both gears on the shaft and pretty much retain everything else. The new larger gear will replace the smaller clutch gear. This is how the gears will be oriented when we do the final install. With the output shaft in the case, slide the new gear into place. Install the output shaft bearing. It has a light press fit and it can easily be tapped into place. Just make sure it's fully seated. Slide the race in place and just start the cover bolts by hand just to help keep that race in place while we move to the other bearing on the shaft. With the new gear and output shaft pushed flush against the case, install the front output shaft bearing. It won't take much pressure to install the bearing, but a tiny bit of heat really helps. By heating only the inner race, the bearing will expand slightly and install with just a light tap of a small hammer. We used a small piece of pipe as an install tool. You could probably just use a punch and a hammer to tap it on as well. Orient the shift forks in the case as shown. Reinstall that front output bearing cover assembly while sliding the shift forks onto the shift rods. This is going to take some juggling, but by encouraging the shift forks, it'll go right into place. You'll find a gasket in your kit, but we just chose to use some silicone. Position the shift forks on the shift fork rods so that the set screws will drop in and index into the recesses in the shift shafts. Final tighten the set screw in the shorter front output shift fork and just loosely tighten the set screw in that longer rear output shift fork. Install the 5 output cover bolts. Now we just added a touch of silicone on each of the bolts. Those bolt holes go clear through the case and have been known to leak. On this install, we're changing out that rear output with TeraFlex's heavy-duty 300 output shaft kit. This replaces one of the weakest links in the Dana 300 transfer case with a 32 spline output shaft that vastly improves the strength. A new needle bearing is provided in the kit and needs to be installed in the output shaft. Look closely at the bearing. One side is more open and the other is closed over. Install with the open end down. It will easily tap into place. To give you an idea of what will be replaced and what will remain, we have the original output stacked in its assembly order. The housing will be replaced along with the bearing by a new housing that will accommodate a larger bearing. The output shaft itself and the rear output clutch gears will also be replaced with a new output shaft and clutch gear. We will retain and use the original shift collar as well as that front bearing assembly. The input gear will, however, be replaced as well. To replace the input gear, remove the snap ring. If the gear doesn't slide off, just turn the assembly upside down and drop it onto a hard surface while protecting that bearing surface. It should just drop right off. We need to replace that seal. And it's possible to just pry it out of the housing, but it's a simple task to remove the snap ring, the input and bearing, and just drive the seal out. You'll probably need to once again drop the assembly onto the input shaft to dislodge the bearing. Give that bearing a quick spin and make sure it feels free and smooth. With the housing empty, it's a simple process to drive out the seal with a punch. Wipe out the housing and tap in the new seal. Any impact to the seal center would be bad. Check to make sure the seal is installed flush with the housing and wipe a little grease on the seal and input. Reinstall the bearing and input assembly. Luckily, I found this giant socket that works perfect to support the housing. You could also do the install in the open jaws of a vise or just find a couple of blocks of wood. Reinstall the snap ring and just make sure it's fully seated. Install the new gear and snap ring and orient that snap ring with the rounded edge of it down. The sharp edge should be up. This is how the assembly will look when it's installed. You'll need to loosen the shift fork set screw that we previously hand tightened to gain access for that new gear. Drop in the new gear with the smooth side out and install the heavy-duty output shaft. Install the output bearing, but don't forget the spacer behind the bearing. Final tighten the shift fork set screws and install the shift collar. This is how we took the shift collar out. With the numbers facing out, that's how we're going to put it back in. Wipe a little grease on the bearing surface of the input shaft and run some silicone around the seal surface. When the cover is aligned and ready to be bolted into place, give each bolt a little wipe of silicone. Again, the holes go clear through the case, and they've been known to be a source of leakage. Torque to 22 to 32 foot-pounds. Install the bearing race into the new output housing. Now the race may go in a little tight, but in the spirit of our caveman install, sadly, we will not be using a race install tool. Once the race is even with the housing, you'll need to tap it in. You'll need to use a punch on that last little bit. It'll become apparent when the race is fully seated. You'll have a very solid feel to it. Use the same process on the remaining race, but be very careful not to damage the housing where that seal will need to be installed. To fully seat the race, you'll need to use a soft punch until it's fully seated. There's definitely easier ways to do this. It's called a bearing race install tool. Install a speedometer spacer, the gear, and then the thick speedometer gear spacer, followed by the preload shims. We won't use any silicone just yet on our housing because we'll probably need to remove it a couple of times to get our bearing preload set. Install a couple of housing bolts. And the rear output yoke and bearing. Tighten the yoke and nut and check for end play in the output. In our case, we have a lot of play, so we're going to have to remove the yoke and most of our shims. Now you can just fish those shims out, but if it gets to be a pain, just undo a couple of the bolts and take that housing back off. We didn't put any silicone on it so we could do this. Tighten the yoke again and check for not only end play, but also bearing preload. Bottom line, it needs to turn with light resistance and zero end play. If you have a torque wrench, we're looking for no more than 10 inches of drag, which barely moves the needle on this bad boy torque wrench. Remove the cover and coat the housing seal surface with some silicone. As before, it's a good idea to coat the bolts with some silicone as well. Tap the housing into place and torque the bolts. 22 to 32 foot-pounds is what we're looking for, if you're all about that torque wrench thing. Carefully install the output seal. Wipe it with a little grease. And finally install the yoke. It doesn't hurt to add a little bit of silicone on those splines. Torque it to 90 to 100 foot-pounds, or just hit it hard with your impact. It's a pain to hold the yoke while you're trying to use a torque wrench, so no one does. You'll be fine. Install the speedometer gear assembly. Notice that the gear is offset in its housing. By turning the housing, the drive gear can be engaged into the nylon gear on our new output. Give the output a turn and make sure that the speedometer gear is fully engaged. You can double check by lightly loading the speedometer output. In preparation for the new intermediate gear installation, liberally coat the side thrust washers with grease. It'll help hold them into position. Be sure to use the indexing guides on the washers to position them in the housing. I wiped out the case and added a thin film of silicone to the housing where that intermediate shaft will ultimately push through the case. Probably not necessary, but I hate leaks. Gather up all 48 needle bearings that were originally in the intermediate gear, as well as the 3 spacers. Coat the inside of the new intermediate gear with grease, enough to hold those bearings in place during install. First, install the center spacer to give the roller bearings something to rest against, while the rest are being stacked into the gear. When they're all installed, there should be no gaps. Drop in the outer smaller ring and repeat the process on the other side of the gear. The O-ring supplied with the kit is a round O-ring. It will have a larger diameter than the shaft's original square cut O-ring. Not to worry. When the shaft is installed, it will be trimmed to fit by the machined surfaces of the case and the intermediate shaft. Partially install the intermediate shaft until it is flush with the thrust washer that was previously installed. This will keep the washer in place during gear install. Use your hand to keep the washer in position on the opposite side. Lower the new low-range intermediate gear into the housing. Be careful to make sure that those thrust washers don't get shifted in the process. By turning the gears, you'll be able to slowly lower the assembly into place. Align the lock plate slot in the intermediate shaft and carefully install it. Use a dead blow hammer and drive the cross shaft into place once you're certain everything is in alignment. With the shaft installed, you'll be able to see that O-ring was trimmed to fit. Install the lock plate and bolt. The only cover that we haven't used silicone on is that front bearing cover. So remove the cover and the shim pack and apply a very light coat of silicone to the shims as well as the cover. It's a machined surface, so don't get carried away. You can add silicone to the bolt threads here and then torque them to 20 to 32 foot-pounds. Move back to that front output and carefully install the seal. It's okay to hit it with some grease. Use a little silicone on those yoke splines again, tap it on, and tighten it up. We're going for 90 to 100 foot-pounds, so just hit it hard with your gun. Let's run through the gears to make sure it all shifts nice before we put the final cover on. The input and the outputs are both turning at the same rate, so we're in 4 high. Now the input and the rear output are both turning together, while the front output is stationary. We're in 2 high. Next, we're in neutral. Everything spins free. The input and rear output are turning at different rates, and the front output is spinning free. We're in 2 low. And finally, we are in 4 low. Use a little silicone or just install the gasket dry. I'm all about the silicone, so we added a little bit to both sides of the gasket and installed the cover. Wrap some Teflon tape around the breather and install it into the speedometer housing. At some point, you're going to need to fill the case with some 90 weight gear lube, and you'll be good to go.